This lesson is about solving for x using the zero product rule. The zero product rule states that if you multiply two terms to equal 0, then one or both of the terms must equal 0. For example, a times b equals 0. Since a times b equals 0, it must be the case that either a equals 0, or b equals 0, or both a equals 0 and b equals 0. This may seem very obvious, but a quick game will show how powerful this fact is. Here's the game. I am thinking of two numbers that multiply to equal 20, such as a times b equals 20. Can you guess my numbers? You shouldn't bet any money on it. It could be 1 times 20, or 2 times 10, or 4 times 5. But it could also be decimals, like 0.5 times 40, or 0.1 times 200. Unfortunately, there are infinitely many possible pairs of numbers that multiply to equal 20, so you might be guessing forever and lose all your money. However, as soon as the game is, I am thinking of two numbers that multiply to equal 0, then you can immediately guess one of my numbers with complete confidence, 0. In fact, both of my numbers could be 0 for all you know. The zero product rule is simple, but it is a powerful tool that will allow us to solve for x in quadratic expressions such as this, standard form ax squared plus bx plus c equals 0. In fact, this is why we always set our equations equal to 0, to use the zero product rule. For example, solve for x in x squared minus 8x plus 15 equals 0. First, you can factor the expression into x minus 3 times x minus 5. Now, the zero product rule tells us that this expression will equal 0 whenever either x minus 3 equals 0 or when x minus 5 equals 0. We will solve both possibilities. If x minus 3 equals 0, we know x must equal 3. If x minus 5 equals 0, we know x must equal 5. Now we know that both x equals 3 and x equals 5 will make the original equation true. Let's check. If I plug 3 into this equation for x, I get 3 squared minus 8 times 3 plus 15 equals 0, which simplifies to 9 minus 24 plus 15, which does in fact equal 0. It's true. Next, plug 5 into this equation. 5 squared minus 8 times 5 plus 15. That simplifies to 25 minus 40 plus 15, which also equals 0. So yes, we have in fact found the only two numbers in the universe that you can plug into this equation that will make it equal 0. Here's another example. Solve for x in x squared plus 3x minus 70. First, you must factor the expression in order to use the zero product rule. Something times something equals 0. Set each binomial equal to 0. After all, either that must equal 0 or that must equal 0. You solve for x in both cases, and it's either x equals negative 10 or x equals 7. And if you plug those numbers into the original equation, you will see that indeed they both equal 0. Here's one more example using factoring by grouping. So you factor by grouping. You group the first two terms together in a parenthesis, and you group the second two terms together in a parenthesis, making sure to put a plus sign in the middle because the negative 9x, that negative has to go with the 9 inside the second binomial. Now you find the GCF of the first binomial, which is x squared. You find the GCF of the second binomial, which is negative 9. And you'll notice that this binomial and this binomial are the same, which tells you that you're doing it right. There is in fact an answer. X minus 5 is the first binomial, and the leftover bits, x squared plus negative 9, becomes the other binomial. Now we set both of these equal to 0 using the zero product rule. So if x minus 5 equals 0, you add 5 to the other side and you get x equals 5. If x squared minus 9 equals 0, well, we add 9 to the other side, canceling the 9 here. We have x squared equals 9. We square root both sides of the equation, and we get x equals 3 or negative 3. These are our solutions. There are 3 solutions because the highest power on x was a 3. Always check your solutions, and you see that I've gone through the detailed work of checking that each of my answers, when I plug them in, really does end up with 0 equals 0. Here are some practice problems for you to try. You'll use simple factoring techniques on the first two and factor by grouping on the last one, and you can check your answers on the last screen.